Water quality affects the environment, agriculture, and communities. The health of our lakes, rivers, and streams has a big impact on drinking water, food, and access to recreational sites, both locally and downstream. I'm Nicole Haverback, and this is Emma Eldridge with the University of Illinois Extension and Illinois Nutrient Loss Reduction Strategy Team, where we work to help communities improve water quality through agricultural production, wastewater treatment plants, and stormwater runoff. Research shows that solutions for improving water quality are often found in nature itself. To sustain their crop yields and production, Midwestern farmers use tile drain systems to move water away from the field and apply essential nutrients for the crop, like nitrogen and phosphorus, as fertilizers. However, some of these nutrients are washed into local streams and rivers where they make their way downstream. Nitrate nitrogen is a nutrient that can be highly mobile with the water, so as the water is moving through tile drains, nitrate nitrogen is moving with it. One tool that farmers can implement to reduce nitrate nitrogen loss for tile drains is a saturated buffer, which treats the water with natural processes before it enters a stream or river. A saturated buffer diverts drainage water at the field edge and redirects it through a vegetated buffer that can be made up of perennial plants.
So how does a saturated buffer work? A control structure diverts water from the main tile line, allowing it to flow underground through a lateral tile pipe within the buffer. This lateral tile is perforated, allowing the water to soak through the soil. As water seeps through the soil, natural processes convert the nitrate nitrogen in the water into harmless nitrogen gas, while plant roots absorb the remaining water and nutrients. When the tiles are flowing, water comes into the first chamber of the control structure from the field. Once the first chamber fills, the water begins to pour over the first set of stop logs and fill the second chamber. At the bottom of this second chamber, there's a perforated tile line called the distribution line that extends laterally into a buffer zone. As water enters the second chamber, it can then flow into the buffer via this distribution line. If there's so much water that the second chamber fills up, the water pours over the second set of stop logs into the third chamber, which is connected to the main tile outlet. This water bypasses the buffer and flows into the nearest stream, so there would not be an issue with water backing up into the field.
Saturated buffers have many benefits. They're relatively easy to install, require little maintenance, and have a lifespan over 15 years. Saturated buffers do not significantly impact drainage or crop yield, and research shows that on average, saturated buffers reduce nitrate nitrogen loss by 40%. A vegetated buffer also serves as pollinator and wildlife habitat. They can be easily paired with other conservation practices in the field, such as cover crops or reduced tillage, which are both practices recommended by the Illinois Nutrient Loss Reduction Strategy.
So what are some things to be aware of when it comes to saturated buffers? Firstly, installation costs can be offset through cost-share funds available through the U.S. Department of Agriculture's Natural Resource Conservation Service. Also, not every field is suited for a saturated buffer. Highly erodible or unstable stream banks may not have the necessary conditions for success. And a buffer, whether existing or new, needs to be at least 30 feet wide with perennial vegetation. Plus, saturated buffers usually have tile distribution pipes that are at least 400 feet long. The buffer soils need to have at least 1.2% organic matter or 0.75% organic carbon in the top 2.5 feet, and there should be a tight layer within the soil profile that allows saturated conditions to develop in the buffer soil. There cannot be a sand lens or gravel layer. By embracing innovative solutions like the saturated buffer, we can protect our water quality and maintain productivity in the field. Learn more by visiting our website, go.illinois.edu/nutrient loss.